This is the year 2040. Foreign trips are old news now. Humans are obsessed with space tourism, zero-gravity honeymoons, orbital parties, and wild adventures in the stars. Things have changed, and they're only just beginning. There was a time when orbit was silent, a time when the idea of living, working, or even visiting Earth's edge was reserved for a rare breed: astronauts, engineers, cosmonauts, scientists. A place where silence wasn't just golden, but absolute. But not anymore. Year 2040. Look up now, and the heavens shimmer not just with stars, but with steel and glass, ion drives and solar sails, moving like sentinels in low Earth orbit. What you're seeing isn't science fiction. This is the orbiting metropolis. And it's real. It began small, fragile, modest. A single outpost, the International Space Station, launched in pieces, bolted together by human hands and robotic arms. For decades, it circled the Earth like a lighthouse in space, a symbol of unity between former rivals: America, Russia, Europe, Japan, Canada. A reminder that cooperation could extend beyond gravity. But there were limitations. The original station wasn't built for tourism, nor business, nor autonomy. It was a lab, a miracle of engineering, yes, but a machine from a different era. Meanwhile, Earth changed. Companies that once launched satellites began launching people. Rockets that were disposable became reusable. The cost of reaching orbit, once measured in millions per seat, fell by more than 90%. Suddenly, the sky wasn't the limit, it was the destination. By the end of the third decade, private modules, small, sleek, often automated, began appearing in low Earth orbit. Some were research hubs, rented by universities. Others were luxury observation pods, orbiting hotels for the ultra-wealthy. But amidst all this, another structure quietly grew behind the scenes, away from headlines. The Second International Space Station. Planned for years, delayed for more. Its earliest pieces were launched in a modular sequence, carried aboard next-generation launch vehicles that could carry double the payload at half the cost. The design was revolutionary, a truss-based backbone, allowing future expansion like never before. Docking ports on all sides, rotating modules to simulate partial gravity, habitation rings, laboratories, greenhouses. And unlike the original ISS, this one had private contributions from the start. Half the modules weren't built by governments. They were leased. One company developed a sports lab testing how muscles and balance behave under microgravity during fast motion. Another installed a zero-G manufacturing facility printing specialized alloys, impossible to create on Earth. A Japanese consortium grew protein crystals. A Singaporean startup filmed the first full-length movie entirely shot in orbit. Tourism was no longer a novelty, it was an industry. With over 12 private or semi-private stations now operational in LEO, competition fueled innovation. Modular platforms could be docked or detached, like Legos. Climate-controlled transparent domes allowed guests to stargaze in their sleep pods. Some stations offered just 3-day orbital getaways. Others, month-long research residencies. But amidst this orbital renaissance, the second ISS remained the crown jewel. Construction was meant to be completed 8 years ago. It wasn't. The delay wasn't due to failure, quite the opposite. The space industry boomed, but priorities shifted. Nations poured resources into lunar ambitions, Mars simulations, and asteroid mining trials. Robotics took over the harshest tasks. Human presence was no longer the only means to gather data. As governments chased deep space, orbital infrastructure became the domain of corporations. Still, the second station endured. Module by module, the skeleton of a new kind of outpost emerged. And now, at last, it is whole. Spanning over 200 meters, it's 3 times larger than its predecessor. Artificial intelligence monitors every subsystem. Radiation shielding is dynamically adjusted based on solar activity. Solar panels expand and contract, tracking the sun's rays across orbits. And perhaps most impressively, a toroidal ring, slowly rotating, provides adjustable artificial gravity. Not full Earth gravity, but enough to prevent long-term muscle atrophy and bone loss. Crew members rotate between full microgravity and partial gravity for physical conditioning. It's the kind of structure once imagined only in science fiction. Think of the quiet solitude of Captain America living aboard a space habitat after retirement, except this isn't a Marvel movie. This is real. Engineered, fabricated, and assembled piece by piece in orbit. This ring represents decades of research into how humans can live, not just survive beyond Earth. Life in orbit has become less alien, more sustainable, more human. Step inside the central ring, and you're in the hub. From here, spokes stretch outward like a starfish. One spoke leads to the science deck, a place humming with experiments, atmospheric studies, cancer research, protein folding. The experiments don't stop. This deck never sleeps. Another spoke connects to the greenhouse module. Plants don't just survive here, they thrive. Root systems adapt to fluid dynamics, unlike anything seen on Earth. Rows of lettuce, tomatoes, basil, mushrooms. They're not just for study, they're for dinner. Food grown in space, consumed in space, recycled in space. Sustainability is no longer an option. It's the only way forward. In the habitation wing, silence is sacred. Crew members rest in personal compartments, each with a window, each with a view no Earthside hotel can replicate. Outside, an endless ocean of stars. Below, Earth turning silently. Every 90 minutes, this city completes a full lap around the world. 16 sunsets a day, 16 sunrises. Sleep cycles are maintained with artificial lighting and circadian adjustment protocols. Sleep science has evolved here: blue light filters, AI-controlled light cycles, and soundscapes generated from Earth's natural biomes. From orbit, your mind remains tethered to Earth, even as your body floats in stillness. Beyond the ring lies the docking array. It's never empty. Arrivals happen daily. Not just cargo craft, but passenger vehicles, sleek, autonomous, piloted mostly by software. They dock with magnetic precision. One carries a pair of doctoral researchers studying dark energy. Another brings a pop star filming her next music video. One carries engineers with tools to 3D print satellite parts in microgravity. Diversity defines this era. No longer is space reserved for one flag, one language, or one uniform. Now, space is layered, scientific, commercial, artistic, and the second International Space Station stands at the center of it. Yet, even here, there are limitations. Gravity remains a distant luxury. Medical emergencies are complex. Even with advanced diagnostic tools, evacuation to Earth takes time. There's no room for error. Crew selection is rigorous. Resilience, psychological and physical, is paramount. Mental health modules now include VR immersion therapy, real-time Earth connections, and mood-adaptive architecture. But no amount of technology can replace a warm breeze, the smell of rain, the grounding pull of gravity. For all its brilliance, the orbiting metropolis still orbits Earth, still looks down at the world it emerged from, still dreams of going farther. Just outside the station, small satellites swarm CubeSats and microprobes conducting everything from climate surveillance to exoplanet imaging. They're repaired in orbit now, not discarded. Drone arms pluck them from the void, patch them, update them, and release them back into the dark. Below, the Earth watches. Students in Nairobi guide robotic arms. Interns in Sao Paulo analyze orbiting data packets. A grandmother in Kerala sends a message to her granddaughter who floats in Module C5. Space has become participatory, not just for astronauts, for everyone. The question arises, what comes next? If a space station can host scientists, tourists, engineers, athletes, and artists, what else can it become? A launch pad to the moon? A gateway to Mars? A permanent human colony in low Earth orbit? Or perhaps something stranger, an interstellar relay, a data vault orbiting Earth's memory, a cathedral to thought floating above the clouds? The answers aren't written yet. but the station is ready. And so, above the turning Earth, it spins. Not aimlessly, but deliberately. Its presence marks a transition from exploration to habitation, from temporary to enduring, from exceptional to expected. In a way, it mirrors our cities. What once began as camps became villages, then towns, then cities, then megacities, then skyscrapers, layered, luminous, complex. Now, above Earth, the same pattern unfolds. An orbiting metropolis still young, but growing. Still fragile, but unafraid. A silent revolution written in steel and sunlight. And somewhere inside, a child floats, the daughter of a researcher, raised between worlds. She sleeps in a room with no ceiling, wakes to the glow of Earthlight, and dreams not of visiting space, but of calling it home. In the next episode, we will see how humans begin living full-time on the moon in the year 2045.